trying to make that appetite make sense for gaming has been a very interesting challenge. Absolutely. And actually, what time is it? Is it that time? 3 more minutes. All right, so the door's closed, so shall we get started? Thank you everybody so much for coming to my talk, Automating Threat Modeling, Challenges in AI Solutions. Just to give you a little overview on what we're going to be discussing today, we're going to very briefly go over what threat modeling is, if that's a new concept for some of you folks, talk about some of the limitations of threat modeling. I'm going to go through a demo and show how we can actually apply threat modeling in making something called an attack tree. If that's a new concept for you folks, then this is going to be a really exciting time to jump in and understand what that is and how we can actually automate that. And then we're going to also jump into some AI challenges when actually creating some of your own threat modeling tools. So a little bit about me. So I am Audrey. I am a gaming cloud security architect over in Microsoft Gaming. I work with Xbox and all of the game studios. It's been very challenging. I'm the Azure and Entra person over there, so definitely have a lot of scope. I got my master's from Johns Hopkins University in cybersecurity. Other than that, I got my undergrad from the University of Cincinnati in computer science, and I love to cook, create, learn a bunch of things. I basically make everything from scratch. So if you're also a cook from scratch, let's talk recipes. I love to talk about recipes. Also a big gamer. I'm a big PC gamer, so if that's also something you guys like doing, happy to game with folks as well. Here's some of my favorite games. I would still say that that list is still pretty relevant, even though there's a lot of really cool games that always keep coming out. Also, my favorite book series is definitely Jim Butcher's The Dresden Files. It's really, really interesting. If you guys are interested in the sci-fi fantasy stuff, I super recommend picking that book up. All right, so let's jump into it. So at a really high level, what is threat modeling? Right, so threat modeling is the process of identifying, evaluating, and addressing potential security threats in a system or in an application. It helps to understand what threats exist, how they could be exploited and what can be done to mitigate them. It's like creating a blueprint for defense, ensuring that security is built in from the design at the get-go. Here you can see like a really high-level overview of the basic algorithm that we can actually apply for a threat model. So it starts with identifying, getting all of those architectures and documents in front of you, so you can see like basically what the system is that you're actually going and designing, applying some of those threat modeling frameworks, like you hear about Stride, you can use OWASP. There's so many out there to choose from, generating some of those threats, providing with some mitigations for some of those threats, and then creating some like backlog items. So that is really high level. This talk isn't about really like what is the threat modeling process, but in order to really understand the tooling that goes behind it, we need to understand the basic high level algorithm here. So let's talk a little bit about limitations of some of those threat modeling tools. So while threat modeling tools, they really do offer valuable capabilities, they do come with several limitations that security engineers really should be aware of. One major issue is that many tools, they do rely on outdated algorithms and outdated threat databases, which can miss a whole new emerging threat landscape if some of you are relying on some of those tools. This is very problematic, especially in this fast evolving landscape of cybersecurity where new vulnerabilities and attack vectors, they're constantly emerging. So I am from Microsoft. We also use some of the Microsoft tooling, which I think we've all used potentially. If not, it's kind of sad. It's really, really outdated. And like as a Microsoftie, like people probably hate me saying that, but it's very difficult to scale and use threat databases and threat and service databases that are really, really outdated. It's just going to give you a threat model that's not super achievable and actionable. Sometimes also, like some of those threat modeling tools, they lack the ability to understand the context and the nuances of the system, which also provide a lot of challenges when you're using them. For example, if you're utilizing like multi-cloud type architectures or like a hybrid type of architecture with on-prem and cloud solutions, sometimes threat modeling tools can really miss some of those threats and mitigations with some of the nuances and challenges of actually doing some of the communication between those two types of systems. Scalability is also a challenge here, where many tools struggle to handle some of those very large complex systems. It's also really hard to scale that out to just folks actually creating threat models. So like they have to go in, they have to learn the system, they have to go learn the tools in order to go generate some of those threat models. And furthermore, a lot of the threat modeling tools, and I like to pick on Microsoft since I work there. Some of those outputs from the tools, like some of the Microsoft threat modeling tools, for example, they provide really, really high-level outputs. And that is really difficult for developers to really grok. Okay, I understand that you're saying that this is a threat, but can you explain to me like why this is a threat, and how can I actually go into my system and mitigate that in my code? And that's just some of the problems that I've been seeing with some of the threat modeling tools. I've used quite a lot of them. And I'm not saying that it's like that with everyone, but every single tool I've used at least had some type of a flaw in one of those buckets. Now, if you're not going to use a threat modeling tool, what's the other option here, right? Manual threat modeling. And manual threat modeling is, it offers also a lot of significant challenges. And it has its limitations. One major challenge is the time and effort required, right? Because manual threat modeling can be a really labor-intensive process, and it can also take considerable time to do a thorough analysis of a system, and then it can also slow down the development process as well, because we're asking folks to understand their system at many different layers, like understand it at the networking layer, understand it at the identity layer, understand it at the service layer, because that's what we're really trying to suss out in these threat models, is what is the current state of your system, and how can we actually potentially find issues with that diagram in that manual threat model or that tool, and how can we mitigate some of that and put some of those in your backlog. Another big issue with manual threat modeling is the lack of consistency. So basically, one engineer can do a threat model totally different than another engineer, and some people even lack the contextual understanding of what it is they're even looking for. Because a lot of the times engineers, they're sitting in your, in your dev teams, and they're there to really make code work. And it's kind of an interesting challenge to get them to change their mindsets a little bit, to figure out, okay, how do I actually make the system that I'm creating? What are some of the flaws there? Like, what can someone do to potentially exploit like what I'm building? And yeah, before I kind of went over this, but here again is the high-level threat modeling algorithm that I went through, and these are the different phases that I'd really like to highlight for the rest of this conversation that we're going to be having here. Basically, like, what can we do from an AI perspective, or just like an engineering perspective in general, to go in and automate some of these bits? All right, so here is the same type of a diagram, but I've actually color-coded it. And I'll go through this in case some of you are colorblind, and I do apologize for that, for not like having it more obvious, because they are kind of similar colors. But so basically everything that I have here in green, which is analyzing the existing system, identifying threats, creating mitigations, those are actually pretty easy to do with AI. Some of the challenges with using AI to help us create threat modeling actually lie in continuously iterating and verifying that. I'm not saying that that's impossible. I'm just saying that's a really tough, challenging area. And actually designing those data flow diagrams. That's also very challenging to do with AI. And the reason why that's challenging to do is because a lot of the times when you're actually utilizing AI to help you create and generate some of these diagrams, it really has a hard time with very consistent output of whatever it is you're trying to feed to this to actually create diagrams that look like your system. And we can go into this a little bit further into the later slides. But at a high level, I at least wanted to highlight this is kind of the problem set at the moment with AI. Now, how can AI actually accelerate threat modeling? So I'll actually have a demo later where I'm going to show some of the code that I built to help accelerate some of these threat modeling efforts. For example, it's actually pretty easy with AI to quickly find mitigations to services. A lot of the context that I'm going to have here, I'll be talking in like the Azure and Entra clouds. That's kind of where my expertise is, and that's where a lot of my threat modeling lies, is like in the cloud. However, you can snap this to whatever other kind of environment or system that you're using. This is just kind of a high level of what I think AI does really well. And I'll show this in my demo later as well. It's really good at helping you brainstorm some of those threat vectors. It could provide threat modeling reviews for some of the threat models, and that's tooling that I'm also working on within my company, is how can we make like an AI chatbot kind of like have that experience with you where you can actually go and provide a threat model and talk about with this chatbot like some of the mitigations or threats that have been found within the threat model. And it's actually pretty good at analyzing services like from a provided architecture image. And like I said, I have a lot of this in my demo. I don't have the review bit, but I have the rest of them where I can show you how I really stepped through and figured that out and worked with that. One other thing I'd really like to point out here is that whenever I'm creating some of these threat modeling tools, I use RAG patterns. That stands for Retrieval Augmented Generation. So essentially, I'm utilizing a base model, and I'm influencing it with my own data to provide me with better output. So that's really the pattern that I'm going to be employing when we go through the code. And I just wanted to put that out there. Like, you don't have to be a data scientist. You don't have to be an expert in these fields to actually start using these tools. You can, and that will actually give you like potentially more pointed guidance. But you do not have to. RAG patterns are, in my opinion, pretty fast and simple, and you don't have to worry about the upkeep, if you will, of keeping that model data relevant. All right, before we jump in, I know this is an older version of the OWASP LLM 10, but I still think this is a really, really important note over the over-reliance of utilizing LLMs. I think that this has definitely been a big pain point that I've been seeing across many game studios and people in Xbox right now, because Microsoft actually has guidance for folks to try to use as much AI productivity to make sure that they have basically faster productivity with their game development or creating like architectures and whatnot, and seeing how we can use AI as much as possible. However, I think that it's still important to know that anything that AI tells you, you should take a step back and really scrutinize the output here, because there is still problems with a lot of the AI generated answers. You know, a lot of the time you'll see that AI will just give you an answer, even if it's wrong. It just will tell you whatever it is you want to hear. So definitely put on a different hat when you're analyzing some of the AI outputs. It can be absolutely beneficial, but you still need to use your brain to really determine if that's going to be useful output for you. All right, so let's jump into a few demos. So before I actually do that, what I really wanted to highlight in the crux of this talk is we're going to be talking a lot about AI attack trees. And if an attack tree is a new concept for you, let me give you an example of what this means. So basically, an attack tree provides a methodical way of describing the security of a system based on its varying attacks. They're essentially multi-level diagrams where the goal, typically on the goal node typically at the top is what it is you're trying to achieve, and then all of the nodes below that are really a blueprint on how you can actually achieve the goal node of data leakage, for example. And below that contain more nodes to the tree on how can you actually achieve the sub-level of this. We don't actually see a lot of attack trees anymore in threat modeling, especially like in the cloud piece, because quite frankly, they're very hard to do. They're very time consuming, and it actually takes a security person to really create some of these attack trees with dev experience too. Because in order to really genuinely understand how an attack can really be achieved, especially when we're talking about code, APIs, systems, you need to have a really good understanding of this. And that's what makes it also very difficult. And let's be honest, like drawing things out like this in a diagram also takes quite a lot of time. So a lot of what I'm doing in my talk is explaining how can we automate this, as well as finding some of those threats, finding some of those mitigations, and some potentially useful code that we can employ along the way. All right, so I'm going to jump into two different demos. The first one I wanted to demo is how can we use Azure AI Foundry to create attack trees. And then the next demo, I'm going to show how I do it in code. And I think it's really important to show you my process here, because it's really not easy, right? It's not easy to just one day wake up and say, I'm going to go build a tool. We're all busy people, right? Especially if we're in security. We don't have a lot of time to go do dev work a lot of the time. So here's what I wanted to show is the process that I use. I'm by no means trying to say you guys need to go use OpenAI, Azure OpenAI, but this is the process that I use because, again, I'm in Microsoft, so I actually get a lot of access to these tools. So that's why I used them to show you my process. So essentially here in this first demo, I wanted to highlight, this is now, it's called Azure OpenAI Foundry. I think this is a little outdated. It says OpenAI Studio. They merged two different studios into one experience. There's an example of how AI is already going out of, like, already outdated, right? So like, what I wanted to show is we have a deployment here where I can play around with system messages, and I can also feed in data here. And that's really interesting to see because like we can kind of like theory craft. How can we actually build some tools here? And this is a really easy way to see, give your theories like a place to actually find meaning and value to see, do I actually want to go spend those dev cycles to actually creating this tool? So here I wanted to show you, I'm using my own GPT-4o deployment, and I have actually implemented data here within this specific environment. It's a really easy click. I can add my own RAG data, so I did that to influence my model to help it understand more about what the OWASP LLM top 10 is, because for this exercise, I was just saying, okay, like, let's see how we can make an attack tree with something like prompt injection. And I wanted to inform my model of all of the different texts and vectors there as well. So here you have the meta prompt is what it's called, that you actually give to the model for clear instruction. And I really cannot emphasize this enough. Written English and like, the way you actually structure sentences, how concise you are, really matters. Like, depending on like this specific meta prompt, if I actually change a few sentences, it's actually going to give me a totally different outcome. So that's also something to really keep in mind, is that maybe if like the system doesn't entirely give you what you want off the bat, potentially doing a little more prompt engineering on your meta prompts are really going to help you a lot here. So as you can see, I gave it my meta prompt of like instructing it, by the way, you're an AI security expert and your role is to help me create AI attack trees. The nice thing also about AI Foundry is that you can give it an example of like what it is you're really looking for. And that's been really useful for me as well to help identify and see if this is something I could utilize later on in my dev process. And to the right, it's the answer. So basically, I just told it to give me an attack tree on prompt injection. And it actually did a pretty good job of giving me that root node, the sub-level nodes, and the child nodes to that to show me like how actually I can create an attack tree for like prompt injection attacks. Here is another view of that chat playground to show you like I can actually do a lot of model tuning as well without having a lot of dev background to go and do this. Like I can definitely change the temperature settings, which makes it so the model is actually going to be more random, or it's going to be a little bit more consistent every time that you give it some kind of a prompt. And then also the fact that I can add my own data here is just something I wanted to just show high level that it's pretty easy. You just click the data source, you have the data in there, and then that gets injected as a RAG to your AI solution. And another thing that I thought was really cool is that there is a button. If you really liked the configuration of how you used AI Foundry, it will give you the source code for whatever it is that you actually did in that portal. Now, I'm going to be 100% transparent about this. I have never actually grabbed this code and put it in VS Code and ran it, and it worked right off the bat. There's always something I had to do to change it for it to actually even compile. So we're still working on that. Like it's getting better, but there is a little bit you're going to have to do to tweak some of that source code that it gives you. And as you can just see from the high-level configuration, like it's not using security best practices. It's like, what's your client ID in secret? Like, come on. But yeah, we're getting there. I think now like you actually can like assign it a system assigned managed identity, and potentially in the source code it will actually reference that. But I would still say that's something you'd still need to check if you're utilizing this as like a test bed. And last but not least, you can actually do a lot of content filtering and whatnot on the input and output of your system. I can just tell you right off the bat from my experience, if you're trying to be a security engineer and you're trying to find threats, AI is not going to like that. Those content filters are always going to ding like, oh, like what are you trying to do here? Like why are you trying to do that? Like that's actually like going to be a big problem here. So you can actually go in here as well and like kind of modify some of those content filter settings. I know it's like really anti-intuitive for like a security engineer to go and like, oh, but I want all this stuff because I want it to be safe. But like for your own education and purposes of going in and testing some of these things, I'm just really showing you like some of the things that I've run into that have been problematic. And also there's something called a security block list here that you can add things that have matches that potentially come out of that model that you're like, no, that's not entirely like what I want. Let's not like have that as an output for some of the prompts in the future. All right, so let's go on to the next model. So that one really was just more of the click-opsy, if you will, experience on how you can do all of this. But before we jump into that, I wanted to share with you my algorithm that I'm using here to create this code that I have called Attack Tree GPT. It's available on GitHub. It's open source. Anyone can go look at it. It's AU-long-MSFT Attack Tree GPT. So you can go and use that source code as much as you want. It's really the bare bones on basically what this algorithm is doing here. So basically, what I'm doing is I am actually providing my code an architecture. And we'll jump through these each step at a time. It's an architecture image. And the second thing I'm doing is utilizing something called Azure OCR to go and scrape all the words off of that image so that I have a dirty list, if you will, of all the words on an architecture image. I'm passing it to an OpenAI endpoint to get a clean list of services. And then I can pass that to a different OpenAI endpoint with RAG data to give me all the threats. And what I mean by that is I can actually influence the threat endpoint with a threat database so that it actually has a better understanding of all the services and the lists that I'm providing it, and then giving me actual threats that make sense. And then I also have a separate endpoint for giving me back a mitigation, which also is a separate RAG pattern that contains, you guessed it, a RAG of a bunch of different implementation measures and security best practices, and how we can actually mitigate against some of those threats that have been identified by using some of those other RAG sources. And last but not least, using a different endpoint to show how you can actually create an attack tree with a provided service. So here is actually an example of actually walking through this. So there was a threat modeling hackathon that happened last year, and there's actually a threat modeling hackathon happening right now. So sorry if you guys did not go participate in that because it's happening right now. But last year, we were given a prompt which basically had a big architecture like this. And as you can see, this is actually an AWS architecture. I am not an AWS person, so I tried to have AI really educate and help me figure out how can I actually make a threat modeling tool to help me decide on like some threats and mitigations here. So here you can see this was the prompt last year. This was the actual image that I pulled from that. And I created this first basically Azure OCR code to help extract that image data. And that's just going to that OCR endpoint. Now, everything you see on the left-hand side is actually all of the words that it scraped off of that image. And I did a very painstaking task of actually looking through it word by word, because I want to know, right, is this thing actually working? And it did. It actually pulled every single word off of that image here. And as you can see, this is really, at the moment, not a very useful list, because what I care about is I'm trying to find threats and mitigations for some of those AWS services, right? So what I wanted to do is just highlight as well in green all the services that I cared about versus everything that I pulled from that endpoint. And what it did was actually grab me all those services in green, and which is great, right? Like it actually, I looked through the diagram one more time. Oh, sorry, I didn't actually mean to go forward. I looked at the diagram one more time. And everything that is in green is what my first endpoint passed back, which is really, really useful, like right off the bat. That means that you don't have to go parse through that data, or you don't have to look at an image and then like type, okay, like what are the threats for the AWS code star, right? So that's kind of like the first bit of automation help that the code does. Secondarily, now that we have this really awesome list of clean AWS services, we can pass it to our first prompt. And here I really wanted to highlight and show like what kind of prompts that I'm using. You could also look into my GitHub repo and you can grab these prompts. You can tweak them to whatever works best for you and your system. But essentially, I just gave it the context of, hey, you're an AWS security engineer. You're specializing in threat modeling, analysis, and risk. You've been tasked with evaluating the security posture of various AWS services. And then I pass it in the list. That's why it kind of looks weird. And your objective is to uniquely identify service-specific security threats within the list that was provided to you. And here's just one example of what that output looked like for AWS CloudFormation. And it kind of gave me like an overview on like what the service actually was, and then it gave me a list of mitigations. And it was really useful, like for someone like me who's not like an AWS expert, where I had a whole list of this for all of those AWS services that I was working with. So that was also, really, really valuable. Now, the second prompt was around finding those mitigations, right, for each service. So again, in English, like as an AWS security engineer specializing in threat modeling and risk mitigation, you've been tasked with evaluating the security posture of various AWS services. Your objective is to identify unique service-specific mitigations, with the list provided. And here you can see it actually provided with some of those mitigation strategies for the services. What I really wanted to highlight here in this specific example too is I did not actually feed the mitigations endpoint with RAG data for this specific example. So I'm sure if you actually grabbed a security baseline out there for AWS, I don't know what they're called, and fed that into that, RAG pattern endpoint, it would actually do a better job of giving you more specific ones. But for the base model itself, it actually didn't do a terrible job. And then the last prompt, I really wanted to actually create some of those attack trees. So I won't go into this, but basically it's the same thing, but like you are now need the perspective of an adversary. And that's kind of interesting, right? Like telling an AI that you're an adversary now, like have this prompt, kind of looking at this with an adversarial perspective to hack into a system and set clear adversarial goal nodes and leaf nodes. And it did this for AWS CodeStar. Now, one thing that I also wanted to highlight is the structure of how it's actually providing you with that output, because that's super, super easy to actually pass to a tool like Mermaid. And then Mermaid could actually draw out all of those diagrams for you. So it's even taking it a step further, which is like, we have this nicely structured data now for each attack tree, and now it can actually go do the job of drawing it. And I think that that's really, really valuable here as well, because you know, a picture is worth 1,000 words, and a lot of the times when people are looking at attack trees, they really want to just see where do the threat vectors lie within my threat model. So this is really interesting and a way to really accelerate actually creating some of those attack trees. Now, let's talk a little bit more about some of the challenges of working with AI. So prompt engineering, I would say, definitely is one of the first big challenges of working with AI. It actually took me 80% more time to write those prompts than it did to write that code to actually do all of this. And that's something I really want to put in the forefront of people's minds. Like, really, prompt engineering is very, very hard. It's very difficult. You need to give it a lot of clarity, or if you give it too much context, then it could potentially go off of the rails. And like, even like I've seen instances where if you give it way too much context, it'll actually just kind of barf. Like, it'll just give you garbage back, like, as an answer. So that's one thing I really wanted to highlight here is, like, you're definitely going to be spending a lot more times on crafting those prompts for anything that you're doing with AI. Secondarily, another challenge is actually tuning the model. So I spent not just a lot of time on actually prompt engineering, but a lot of time on model tuning. And I don't want to say like fine-tuning here, because fine-tuning is kind of reserved for creating your own models. But if you're using RAG patterns, like model tuning is kind of the more accurate way of saying that. Just to not go into the weeds and jump on like data scientists' language there. But essentially, like, model tuning is very difficult, because a lot of the times AI, if you ask it the same question over again, it's going to give you a different answer. And that, we don't want that, right? Like, we don't want that for a lot of cases. And how you can actually tune that is by that temperature setting that you saw earlier in the AI Foundry page. But you can also do that programmatically. So ensuring that you have the temperature set there, and there's also code that you can add here to say, like, please do this answer like, I don't know, 10 different times, and potentially with, I hate this solution, by the way, with a different AI endpoint, tell me which one of those answers is the best. As you can see, it starts to kind of triage down into an, hey, AI, tell me this, now validate with this AI, now do this for me, AI, now validate over here. So you start to notice some of those trends of over-relying really on like AI to help you find a lot of that same answer. And if you think that this is bad, then wait until you see what your developer's doing. Because they're doing the same thing. I can guarantee you that. So yeah, ensuring those consistent outputs, that can be also difficult. And managing some of those computational resources. I don't know if you guys have really used a lot of some of these OpenAI endpoints, but they actually take something called tokens into consumption when they're actually going in and doing these calls in the back end. And that's really taking account of how much context are you giving it with like characters, and it's really transforming that into like token consumption. And it's finite. So what you'll start to also see is potentially you don't have enough tokens to do exactly the job that it is you want to do. So that's also something to consider when you're actually utilizing AI to help you create some of these tools, is that it's really difficult to actually do some of that resourcing with the AI endpoint. All right, let's jump to inaccurate responses. this is another big challenge of working with AI, is essentially some of the outputs that you're giving it, or that it's giving you, are actually really inaccurate. It's making it up. And I love when you ask AI to give you a link, it almost never gives you a link. It always just makes something totally up. So that's also something to consider when you're actually looking at AI and telling it like, hey, what's your reference for this? And sometimes it's like, oh, it's this thing, and like that thing doesn't exist. So that's also like a really fun tip to like see, like, is it actually pulling from data that it should be, or is it just kind of making it up? So that's one mechanism that I've used to really like kind of gauge some of that. But as you can tell, that's actually really that's time-consuming work, right? Like that's not easy to like really figure out like how does a system like AI that you cannot really change, like how it's like responding to you and giving you answers, like how can you make it so it's actually not just making things up? So that's a really, really big problem with AI, and something that I also think I would like to like put in the forefront of your minds when you're actually going and generating some of these systems. Like that's why you always want to keep a human in the loop. You always want to double check. Like this is a tool that I'm using for developers as well, like in Microsoft. My team actually has taken this source code that I've written here, and we're generating at the moment a threat modeling tool for gaming. And I can tell you that we do find a lot of really weird things happening when we're actually creating our own tool, right? Like what I'm going to provide is just like a really bare bones version of like what we're creating right now internally. But this is definitely one of the biggest problems that we see, is like how do we actually ensure that we're getting consistent answers? Because we're going to have a lot of threat models potentially using the same service. However, we want those to be the same type of answers. So that's a challenge that we're actually trying to overcome at the moment. And let's talk, I already kind of covered this very briefly, but availability and cost of those models. It can be quite expensive. And also I've seen a lot with like Azure OpenAI specifically calling that one out. Sometimes the service endpoints go down, and you don't really get a lot of notice on that. So that's also something to consider, like ensuring the availability of those endpoints. And whenever you run out of tokens, like it will actually just crap. Like it will not tell you, just like, sorry, you don't have any more tokens, you can't complete this action. And that's something that you also wanted to consider when you're building tools. Like I said, for me, I'm building an internal tool, so a lot of devs are going to work on it. But if you're going to use a tool or build a tool for external folks, these are things you need to consider, having that service uptime. And another really, really big problem area here is getting that fresh, relevant data. So this is actually quite challenging in general if you're building a model or if you're utilizing a RAG model, because you need to make sure you have some kind of automation to ensure you're always going to be giving that fresh data to your RAG pattern or for the model that you're building. And this is also, it could be quite challenging if you don't have the dev skills, or like you don't have a dev team to go and do this, but I would say this one's really, really important, because if you don't keep fresh, relevant data in your RAG, then you're going to fall into the same pattern that all the other threat modeling tools out there currently have, which it's not going to give you relevant information because it's always going to be a little behind on potentially the most current threats and mitigations there. So always making sure you have some kind of a data ingestion pipeline. It would be great if some people actually like threw their threats and mitigations in like an easy to consume location like GitHub. But as you have probably all are aware, that's like not entirely the case for a lot of people. Microsoft is generous in regards to putting their security baselines also in a repo, so that it's easy for me to consume from the Azure perspective. But in regards to like whatever it is you're working with, like it could be potentially difficult to find some of those sources that are also relevant and fresh, right? Getting the fresh, relevant sources to pull into your RAG endpoints, like that's a really big challenge as well. And last but not least, keeping up with the tech. So I created this talk like really not that long ago, maybe 6 months, and I've done it a few times now. And there's already things in here that are already out of style. Like for example, it's called Azure OpenAI Foundry now instead of like Azure OpenAI Studio. And a lot of the models get changed, model features come out all of the time. And it's really difficult to really keep up with that tech, especially since we're security engineers, we have full-time jobs to actually go out and create security patterns, security best practice, security architecture. How do we keep up with the tech for AI, especially since it's being so relevant right now? Well, that's difficult to do. Like, you have to actually spend time to set aside to actually go to those talks, go to those trainings, like go play with it in the portal, or like make your own tool, because that's the only way I can learn is how to make stuff like this, is by actually going and doing it. But yeah, like even some of the models that I used when I first started creating these tools already are not available. Like the Da Vinci model is not available any longer, for example. So that's always something to keep up with too, is keeping up with AI. And even OWASP LLM, as you guys know, OWASP LLM 10, it's already super different than it was like not even a year ago, and I don't even know how many iterations it's gone through. But that's just another example of kind of like showing like the changes and trends here within utilizing AI. And that's what I had for you today. You know, guys, thank you so much for listening to my talk. Thank you. And I'll be open for any questions. Go for it.
You mentioned that you were able to, with Azure, you were able to feed the security baseline into the model.
Mm-hmm.
What form is that security baseline in?
Yeah, so all the security baselines right now are actually on GitHub. And they're publicly available too. So it'll have like a security baseline for each Azure service. And that is really easy to consume into like your Azure OpenAI search endpoint, so that you can actually feed that into your OpenAI endpoint when you're doing those calls. So that's how I'm doing it on the Azure side. But you know, for example, like I don't know if AWS, GCP, for example, they also have like a nice repo of consumption. Or if you actually have to create some kind of a tool, for example, to maybe, and this is gross, like I don't want to say it like this, but like maybe scraping website data and like making your own thing, and that gets complicated, right? But yeah, if there's like a GitHub repo out there for any other security baseline that you would need, I would say that's the easiest way of consumption.
Very helpful, thank you.
Yeah, no problem. Oh, I'll do this one first.
So I know you focused on attack trees in this talk a lot. Would you say that there are also other diagrams that AI would be good at generating here as well?
So I would say that basically anything that needs a diagram, like right now my team is actually creating data flow diagrams with AI and with Mermaid. And it's challenging, let me just tell you that, because a lot of the times the data flow diagram actually isn't super accurate. So it actually probably, that would be a big challenge, I would say, in the AI space. But if you take AI out of the picture and you make it more of an engineering problem, it's a little bit more achievable. Because then you can really inform like what kind of things go in, and then you can use Mermaid to actually like create those network diagram borders and whatnot around the services. However, the problem with that is that then you have a huge, gross, long format that you have to give Mermaid in order to generate those diagrams. So really trying to find that balance of like, how do I get the format of what I need for a data flow diagram, and potentially have AI help me kind of generate some of that Mermaid code, is like where I'm struggling at the moment, just being transparent with you. But I think there's been some slow progress there. You had a question?
You already asked it.
Oh, cool, awesome. Any other questions? Go for it.
Any ways for students to help with your additional project as well? Just wanted to ask. I know it's on GitHub.
Yeah, it's on GitHub, absolutely. You know, I accept pull requests. You're more than free to go pull it yourselves and play around with it. It is the bare bones, but I think it's enough to get anyone started with understanding how to actually go in and in a code-like way, like create your own, you know, interfaces and whatnot to reference with AI. I don't even have like a UI, so like, yeah, that's an open suggestion if people wanted to create that. Do more Mermaid integration, like absolutely, I accept pull requests, but also happy to just share the code, share the love, because like I had to go experience it, and hopefully it accelerates somebody else if you're interested in building something else yourself.
Sorry.
Oh, you're good.
How long has it taken you?
So for the code that I just shared, and the code that you guys are more than welcome to use, I actually made all of it in a hackathon. So like the threat modeling hackathon that I did last year, it was a 3-week hackathon. And I actually created all of that code during that time period. I actually told my team, I'm like, hey, I'm really interested in trying to like make a threat modeling tool, since in the judging requirement was like, you're not allowed to use a threat modeling tool. But I asked them, like, can I just make my own then? And they're like, sure. So I took that opportunity to go skill myself and learn how can I develop an AI threat modeling tool. Yeah, not a problem. Yeah, go for it.
You said the prompt mitigation, the prompt engineering is tricky.
It's very tricky, yeah.
So the code was actually a lot quicker than the prompt engineering?
Yeah, absolutely.
Is there a conclusion here, or is that leaping to inferring too much? That it's better to actually take the time to develop the software rather than trying to get the model to solve the problems for us?
Yeah, so I would say that's like there's kind of two answers here. I would say addressing your question about prompt engineering first, like that is very challenging to do, and I think that Azure now actually has like a prompt engineering studio that you can go and like help actually craft your prompts to be better. I personally have not used that though, being fully transparent. So there are tools that people are thinking about out there to help you actually enhance your meta prompts. So, but that is still a challenge. Like you still have to very concisely and detailedly think like how are you gonna like give instruction to an AI. So I'd say like, you know, addressing the first part of your problem, that is still a hard problem area. But there are things that people are doing out there to help streamline that. In regards to should you even have AI doing something, right? Like that's a really interesting question because, you know, right now we're in the age where everyone kind of thinks that AI is gonna help you accelerate everything. Like we're all gonna get scripted out of the job with AI, right? It's not really entirely true. Like where we're at in this stage today, like I would say that it's a really great tool, depending on your use case for it. I would say if this tool was ever to be public facing, I would say absolutely don't do that. I would say just use this as like an educational experience for you. But I would say also like for whatever it is you're deciding to build with AI, like you really should take a step back and like understand and evaluate, do you really need to create that system? You know, I know that there are tools out there. Microsoft has one called the Responsible AI Assessment that a lot of people in the business actually go through and look through this evaluation to kind of ask some of those questions, like what's the safety model look like? What's the security model look like? Is this really going to help accelerate? Like what's the problem statement here? Like are we actually solving something that's going to be useful with AI? So I would say like definitely taking a step back and looking through exercises like that to help you really understand like should AI even be needed here? Is definitely something that you should do as a first step. Absolutely. Any other questions? Awesome. Well, thank you guys so much, and I'll see you at happy hour if you have any other questions.